Hi there, Neuro General Assessment. Dr. Ang, and we will be hitting neuro here to start out. We're going to give a little bit of a recap, so more of the science aspect of it, and then we're going to follow up with 6.4, where we're going to find out a little bit more of the nurse's role in the nursing interventions related to specifically the neuro system. So jumping in, Command Central. So our neuro system is pretty much the motor, the command central for our entire body. So the ability to think, process information, make independent decisions, know who you are as a person. It's all referred to as our conscience. This is intellect and sets humans apart from all other species. So it's what's fascinatingly different about humans. Our class learning outcomes, we're going to review anatomy and functions of the neuro system. We're going to discuss stimuli which affect neuroregulatory systems. Then we're going to identify effects of development on the neuro system throughout the lifespan. What's specific to the very young, what's specific to the very old, and then what are some aspects that are going to be general throughout the lifespan. Functions of the neuro system. It maintains, controls, and integrates all body functions by its voluntary and involuntary responses. That's pretty broad, but that also emphasizes how incredible the neurological system is and how big of a role that it plays in our being, in our just mere existence. It controls every aspect of our body, maintains, controls, and integrates all body functions, voluntary and involuntary. And we'll take a deeper dive into that as we go. Coordinates activities of the body, just mere coordination. Can you talk and think and be getting dressed at the same time? Can you coordinate riding a bike? All of these aspects, coordination, are related to the neuro system. Adapts to changes that occur inside and outside of the body. So if there is a snake approaching, or if there's hot water boiling that you get too close, the neurological system is going to come in as command central, take charge of the situation, send messages to the brain, interpretation will occur, and then a response will be elicited based on that interpretation, and allows us to function and adapt to the world around us. I have a video here on this first slide. If you want to watch that, you can. It's on slide 4. Specific functions of the neuro system. Receive sensory stimuli from the environment, as I've just mentioned. Identify and integrate adaptive bodily functions. So how do I know if I need to use the bathroom that I don't just go to the bathroom? How do I know that I'm going to hold that until you get somewhere that's appropriate to take care of that, and then your neurological system sends a message that now, okay, it's time to void. But you don't just, all the things, it regulates when and how you interact with basic needs in life, basic functions of the body. The command central has to say when that can take place. So all bodily functions. And even if although my legs know how to walk, they can't walk without the message being sent from the central nervous system, and the motor pathways going out to say, okay, now we're going to coordinate and we're going to walk, and it elicits that motor response. But it's first interpreted through, and the message sent through the central nervous system. And all of these messages, it's fascinating to me. It doesn't take a lot of time to do it. And many of them are voluntary, involuntary, or almost reflective. It's automatic. It just is once you learn that in that pathway, as well as when it takes of how quickly, if you go to touch something hot, how quickly that message is sent and your arm is jerked away, and knowing that where the message goes and is interpreted and it elicits that response is fascinating to me. Control cognitive and voluntary behaviors. Control subconscious and involuntary bodily functions, memory, thought, speech, and movement. All these aspects are key components of the neurological system. Okay. So, divisions of the neuro system. It takes an army to make this neuro system function and be able to be command central. We have to have all the components coming into play, and it's divided into the first central nervous system and peripheral nervous system. And the central nervous system, which I'm going to refer to as the CNS, maintains network of coordination and control of the body, and it is comprised of two main components, and that is the brain and the spinal cord. It includes cranial nerves 1 and 2. So the CNS is comprised of what? As I've just mentioned, the brain, spinal cord, and cranial nerves 1 and 2. Again, have a video there if you want to watch. I've also put these in Harvey if you'd rather watch them there. The peripheral nervous system, on the other hand, carries information to and from the central nervous system. So we have command central, and then we need, not only that, now we need literally the arms and legs taking that message and implementing in that message. It is comprised of cranial nerves 3 through 12, spinal nerves, afferent and efferent neurons, so sensory and motor neurons. Afferent neurons are carrying the message to the brain. Efferent are exiting the brain, the E exiting the brain, and they're the motor neurons that are taking it to the body. So we're sending the message, so we receive touching the hot, feeling the hot. That is sent with an afferent neuron that goes to the central nervous system that says that is hot, we're going to get burned, we need to pull that hand back. It sends off an efferent E, efferent exit neuron that will pull the hand back before hopefully harm is done or further harm is done. Somatic nervous system is voluntary, whereas autonomic nervous system is involuntary. This is a critical slide to know how the breakdown exists here. And in the autonomic nervous system, then we also have the sympathetic and parasympathetic nervous system. So this is a complex process. This slide right here is going to tell you the aspects that you need to know to have that solid foundation to build on further neuro content. So make sure that you are studying this slide specifically. This is slide 8, and know the difference. I'm going to help you with some of these. I have several videos that I have uploaded if you're more of a visual, want to see another aspect, as well as a couple diagrams. See it as many times as you can, and then once it clicks, it's going to stick and you're going to be able to build on this content. But don't rush that. So you can see sensory input, integration, and motor output. That is the nervous system in a nutshell. Sensory input, then integration, and then motor output. I'm going to sense it, I'm going to integrate and interpret it, and then I'm going to send a message of what I want the body to do about it. So if there's a spider on my leg, that sensory input is going to come in an afferent neuron. It's going to come up to the central nervous system inside of the brain. It's going to be interpreted into integration and interpretation, and then I'm going to send the message out in an efferent, efferent, exiting the brain to a motor output. So motor neurons are then going to take action. Okay. Anatomy and physiology of the brain. You can read down through this. You're just pulling back from your anatomy classes. Just kind of review that. Not going to be heavily tested on this, but it is important. Do make note of the different aspects of the brain, such as aspects that have to do with balance, ones that have to do, what part of the brain has to do with speech, that type of thing. You're going to want to know that, those aspects of the AMP of the brain. Again, brain structures, the main four components you're going to want to know is the cerebrum, cerebellum, limbic system, and brainstem. Have a diagram there for you. Cerebrum is the largest section, and it's divided into two hemispheres, right and left, and then it has four lobes: frontal, parietal, temporal, and occipital. This is all part of the cerebrum. And frontal is for reasoning and thought. Parietal is integrating sensory information, and that's more up here. Temporal is more in this area. It's processing auditory. Think of that. That kind of makes sense. It's near the ears. Occipital, processing visual information from the eyes. This is a fun thing I like to do when we're in class, of finding out, are you left brain or right brain? This is fascinating to me as far as ways, it's just when you hear that of how you're wired, that's legit, that you can see that. If you're more analytical, numbers side of thing, you may lean towards more the right or to the left brain. If you're more artsy, you're more into the creative aspect of things, then you might lean more to the right brain. And there's a little quiz you can kind of take if you're interested in that to see which way that you lean. So cerebrum, gray outer layer is a cerebral cortex. And that's all the folds and the wrinkles. It houses higher mental functioning. So in this case, the more wrinkles you have is the better. The more gray matter, the more folds and wrinkles you have is better for higher order mental thinking. White inner layer, on the other hand, it's the glial cells and the myelinated axons that transmit signals within the cerebrum to the lower brain centers. So just knowing that gray matter, it's good if you have a lot of gray matter, and that's seen with all the wrinkles and folds is where that is housed. So another little fun facts about gray matter on the next slides there. You can see the lobes of the cerebrum. I've already mentioned that. One's spinning. I've tried to do some little animations there where you can see what part of the brain it actually is, but you will go through frontal, parietal again, occipital, and temporal. The reason this is important is if you know you're having, again, issues with balance or problems with interpreting visual patterns, you're going to want to take a closer assessment on that aspect of the brain. Is why that is critical. Again, I'm just giving you a lot of different visuals of the different aspects of the brain. I've got stars on them for you to know which area to focus on. And I'm going to flip over here. I went through a couple slides here. Limbic system. The limbic system supports a variety of functions, including emotion, behavior, motivation, memory. These are all cool aspects, right? Emotion, behavior, behavior, emotion, motivation, long-term memory. That is all part of the limbic system. And then the brain stem. The brain stem is critical because it's a pathway between the cerebral cortex and then the spinal cord. So basically the base of the brain and then the spinal cord, we have the brain stem, and the 12 cranial nerves arise from the brain stem. The 12 cranial nerves arise from the brain stem. The aspects that I'm mentioning, I'm highlighting, are the ones I'm going to want you to focus on. You will see some slides with other aspects in here because I think it's good to know information, nice to know, but it's not going to be need to know information for in relation to the exam. Okay, so we're zipping through. So we've got the brain and the spinal cord. So now let's zip to the other aspect of the CNS, or central nervous system, which is the spinal cord. It begins as a continuation of the medulla oblongata, and it ends between L1 and L2. And surprisingly, this doesn't go down as far as people often think. Nerve fibers grouped into tracts running along the spinal column. They carry impulses between higher centers of the brain and then the body. So this is the message centers that are running through. And they're myelin coated with white matter. And you can see here, we also have a video if you want to see that. The spinal cord is about 16, 17 inches long, just like a general laptop screen. I usually hold that up if I have it here, just kind of as a diagonal. That's about the length. And again, that doesn't seem very long with relation to oftentimes what you think when you think of your whole spinal column. Your spinal cord is actually not that long. And it's less than a half an inch wide, so it is thinner than an average adult's finger. So that just gives you a little bit of insight into the spinal column. Cranial nerves, again, however you can remember these, it's good to have an overall idea of the cranial nerves. I'm not going to hit overly hard on specific ones, but you do need to know in general. You're going to need to be familiar with these. So how I remember these are, on occasion, our trusty truck acts funny, very good vehicle anyhow. That's how I remember it. So it's OOOTTAFVGVA. That's all of them. You can look on there, olfactory, optic, oculomotor. You can read all of them there, but come up with a mnemonic of some way that you can write those out, going cranial nerves 1 through 12. There are some maybe not as appropriate, but other ones that people use to remember it. This is the one that I like. I have it listed here. If you find that helpful for you, then go for it. But just find one that you can come up with to remember which cranial nerves is kind of going with one area. Then that'll help you be able to assess a little bit easier. Peripheral nerves. There are 12 cranial nerves that connect, again, with the brain. And then another 31 pairs of nerve roots that branch out from your spinal cord between the vertebrae. So we're not only going to bring the cranial nerves down, now we're going to branch out, because now we get the message down the spinal cord, it's come through the CNS. Now we have to get that message out to the motor responses in order to elicit action. So again, spinal cord and PNS, you're going to see which ones: cervical, thoracic, lumbar, sacral, coccyx. You can see 8 cervical, 12 thoracic, 5 lumbar, 5 sacral, and then 1 of the coccyx. You can see the diagram there. Important for you to note, afferent sensory fibers, again, are bringing the message to the brain. And then the efferent motor fibers are bringing the message out to the body to take action. So another way you can remember this, afferent with an A for arrive, bringing it to the brain. The message is arriving in the brain. And then efferent with an E, it's exiting. So now it's interpreted. Now we have the message. We know what we're doing. We know the game plan. So now we need that message to exit the brain and go take action. So afferent, the message is arriving at the brain for interpretation. And then efferent is the message is exiting the brain for action to take place. Okay, I have several. Again, it's important that you know also for these nerves, because if you know where an injury is in a patient, where that injury is on the spinal cord, you will know that paralysis will happen below that area. So if you have a spinal cord injury that is in, let's say, chest level, everything below that, there would be paralysis could take place below that. You're not going to have them paralysis above that, because the spinal cord injury, everything is going down, so it would be below that injury. And you can look at that sensory impulse pathways. I've kind of went over that several times. Hopefully that's making sense, but you want to kind of see how that, you have to have the sensory to send the message up for interpretation, and then the motor response will elicit a reaction after that based on that interpretation. But I have that in a couple other slides there. Now we go to the autonomic nervous system. This coordinates and regulates internal organs of the body. Autonomic nervous system, or ANS. Two divisions balance the impulse of each other. We have the sympathetic nervous system and the parasympathetic nervous system. Sympathetic is action, okay? It prods the body into action during periods of psychological or perceived stress. So sympathetic is we're jumping in and we're taking action. Parasympathetic, though, says, whoa, we need to just relax. Okay, so it's more the calming response. Functions in complementary, counterbalances the sympathetic nervous system so that we have the goal of homeostasis. So we've got the sympathetic that's slamming down the gas and trying to take off. And then we have the parasympathetic that's trying to ease off of that and maybe put the brake on a little bit. And that is when we get the homeostasis. If we get that out of sync, we can have an incredibly stressed out individual, or we can, if we're too much falling into the parasympathetic, we can go the other way. So literally we are trying to find a balance, homeostasis, and that is the ultimate goal for the autonomic nervous system. Pay attention to this next slide. It is 44, but this is something that you absolutely are going to want to know, because you want to know what is elicited in the body during each of these states. So parasympathetic, you can look there and see. Parasympathetic is where we're calming, right? So we're going to slow down the heart rate. We are going to stimulate, you can stimulate secretions. This is secreting or digesting your food. These are the different things that not that necessarily critical aspects to the body, but more of a relaxation mode. Whereas sympathetic, when it is hitting the gas and it's in a stressful situation, your pupils are dilating. It inhibits flows of saliva and digestion because it's saying that is not critical right now. Saving my life is what's critical, or dealing with this stress is critical. So they're going to slow down and put on the back burner saliva and digestion and reproduction and those types of things. And what do you think in sympathetic is going to happen with the heart? The heart rate is going to accelerate, whereas in parasympathetic, it calms and slows. In sympathetic, it's hitting the gas, so it is going faster. Let's see what else. That if you just look at that slide, it compares both parasympathetic and sympathetic, and most of it I think will make sense to you when you see it. But that visual is helpful. So sympathetic nervous system, again, is fight or flight. And parasympathetic is rest and digest. So taking care of those things that are not as critically important and just resting in a calm sense. Whereas sympathetic is fight or flight. And what's the goal again? A homeostasis state between both. And again, sympathetic nervous system, an increase in heart rate, dilated pupils, and a decrease in things such as digestion. That is sympathetic nervous system. And then the opposite. So the dangers of constant stress, as we've mentioned, if you always have your body in a state of constant fight or flight mode, everything is a big deal. And this is something that, especially when you're in nursing school, we have to kind of come to grips with this, because, and it's easier said than done, I acknowledge that, but being in a state where everything is stressful and everything is a big deal and you can't calm yourself and get into a spot where you can let your body relax to some extent. Our bodies are not intended to go long term with an increased heart rate, and our pupils are dilated, and our entire bodies are just cringing with stress. We have to be able to balance that off with that parasympathetic nervous system as well. So that's the dangers of constant stress, and it's important because it will affect our heart, our cardiac condition. It can elicit stroke, different things. So if that is an issue, it's so important to develop aspects that we can do that can calm us, or the ability to be able to get things in perspective is critical, because there are dangers of constant stress. Parasympathetic, aka rest and digest as well. Reflexes I've shown. Some things are such an autonomic response, such an automatic elicit such an automatic response, that such as touching fire. We don't need a sensory message to an afferent neurons to go up in a long drawn out process of, well, actually, maybe we should pull the finger back because we don't want to end up in the emergency room because it's packed with people fighting for their lives with corona. And so maybe we should pull the finger back because I think that would be best. And then we send an efferent neuron out to elicit that motor response to pull the finger back. That is not in any way the case. It is gone almost into the form where there's some things are elicited by a reflex of, if something is hot, there's a reflex arc that literally says, we don't have time to even interpret this. We're taking over and we're just pulling the finger back. And that is called the reflex arc. And it's along the neuron fibers. And you can see reflexes we have in here. Superficial reflexes, know what those are. If you can see the abdominal reflex and plantar reflex. You can see those here. And then the cremasteric reflex, that is, so if you stroke towards the umbilicus, you will see it will pull in, actually coming along, same way as if the plantar, if you run your finger or an object along the sole of the foot, you'll watch the response of the fingers. If you run your finger or an object up the inside of a thigh on a male patient, then you will see the testes on that side will actually raise. That is a reflex. These are all superficial reflexes on that slide. Effects of aging on the nervous system. Generally, a rule of thumb is when considering a question related to aging, generally the response is going to be that whatever it is you're referencing, it slows down. So neurons to the brain and spinal column, this process will slow down slightly. Slowing of neural processes in general, efficiency of the autonomic nervous system, brain weight actually decreases, nerve velocity, reflexes are actually going to decrease, as well as response to stimuli and sensation of touch. These all just slowly decrease. Pregnant women in the nervous system, you can check. I have some videos on here that you can watch and some important clips there, as well as for the child. So there's several slides though that are showing you the reflexes of children, and many of these, like for the newborn, as they transition, most of them are going to go away by 12 months to 18 months. Primitive reflexes should dissipate, they should go away. And if they don't, a lot of times that can be indicative of a neurological condition. And that pretty much covers, just in a nutshell, and I know I went through that fast, but if you have any questions about just the general anatomy and physiology of the neurosystem, or how those aspects come together, please reach out to me. I love the neuro system and I'd love to take a deeper dive with you. But for sake of this video here, just wanted to give you a recap. Now, if you can go and watch the other videos that I have provided, I think you're going to find those incredibly helpful, and they're going to help solidify a solid foundation for you to build further neuro content as you progress in future courses as relates. Now, also go to 6-4 and you can learn the specific assessments or nursing implications of neuro as well. But please reach out if I can do anything for you or clarify any questions or concerns.